Hello everyone, this is a video showing you how to set up the software environment we use. I know that this is often something that people have struggled with in the past, so hopefully this video will complement the documentation we have and make it easier for you all. So now the first thing you're going to want to do is you're going to go to the documentation for Virtuoso. So if you are in the main branch on the Virtuoso repo, you're just going to scroll down and click here for the installation directions. And the first thing you'll want to do is install Ubuntu. So if you click on this link, it'll take you to this tutorial. Now the simplest way and the way that we recommend if you are just starting with Linux is to use a virtual machine. We will be using VirtualBox, but there are other VMs that you can also use instead. If you use an ARM-based chip, like the M1 Max, you'll probably want to use a different virtual machine called UTM. And then in general, another option for installing Ubuntu is dual booting it onto your computer. There are significant performance advantages to dual booting it instead of using a VM, and I'd be happy to help you with that if you come by the lab. So this tutorial walks you through how to get Ubuntu set up on your VM, on a VM. So first you'll want to download an Ubuntu image onto your computer. If you scroll down here, it will give you a link. And then you'll want to make sure that you're using the 20.04, not 22.04 Ubuntu version. So if you click on See Our Alternative Downloads, and then Other Images and Mirrors, you will see here that there's an Ubuntu 20.04 download. And so once you click on that, you should get a file that looks similar to this. So if we go to Downloads, you'll see there's an Ubuntu 20.04 disk image file. And so you should get that in your downloads when that finishes. So after that, you're then going to want to download and install VirtualBox, and there's another link for that. Well, that's not loading, but know that, oh, there we go. So you want to go to that link, and then whatever your operating system is, you'll just want to get the correct download link, and then follow the directions to the prompts that it gives you to set it up on your machine. And once you're done with that, you're going to have an application that you can open like this, VirtualBox, and it should give you a window similar to this. You might already have a VM for another thing, but you probably will have no VMs here. So now we're going to create a new virtual machine for our Ubuntu environment. So we click this New button. I'm going to go ahead and call mine MRG, but the name doesn't really matter. You can call yours whatever you want. So for the ISO image, you're going to want to select the disk image that you downloaded earlier. So we'll just select that, and then we'll click Next. You'll want to change your username and password to something you can remember. And then Next. So we recommend using at least 8 gigabytes of memory, as the simulation we use takes a lot of memory. If you can't give 8 gigabytes while staying in the green, that's fine. You can just create the VM with less and then not use the simulation. There's still a lot that you can do without having the simulation running. Additionally, you can also dual boot your computer later on to take advantage of all your computer's RAM instead of just a portion of it. But in my case, I'm going to go ahead and give my VM 8 gigabytes of RAM. And I'm just going to give it 4 cores. So we also recommend creating a VM with at least 25 gigabytes of disk space, and then you can always add more later on if you figure out that you need more space. So now I'm going to go ahead and click Finish to create the virtual machine, and I'll see you guys when we create that. All right, so now that your VM is created, you should see a screen like this. If you want, you can try shutting down and reopening your VM to make sure everything is all right. But now what you're going to want to do is enter the credentials that you provided earlier. And so we'll just skip all this. So I'm going to go ahead and enter full screen here, and you're going to notice that my VM is kind of not very large screen size right now. So the first thing I'm going to do is change my display so it takes up more of my screen. And you can play around with this to figure out which display looks best for you if you want. So the next thing next thing I'm going to do is I'm going to go ahead and log into my GitHub on Firefox and then open up the installation guide we had from before. Okay, so now the next step is to get GitHub SSH set up on your VM. So step 2 right here. So we're going to go ahead and open up the guide. And what you're going to notice is that GitHub provides pretty nice documentation for us on how to do this. So we're going to go ahead and follow the documentation. The first thing we got to do is check to see if an existing SSH key that they use or that we can use is present. Let's just not upgrade that. So we'll go ahead and open the terminal and then paste that in. And you're going to see we don't have an SSH key that would work for them. So we're going to go ahead and generate a new SSH key, and we're going to follow the prompts they give us for that. And then we're going to add the SSH key to our GitHub. So this is just going to display the key, and then we can copy this. And head over to our account settings. And then paste that in. And you should be good to go with your GitHub SSH then. All right, so now we're going to go on to step 3 of the installation, and we're going to go ahead and open up the installation guide that ROS2 provides us. And we're just going to start by running these commands to set the locale. And you may get this error here where it will say your user is not in the sudoers file. This incident will be reported. And so Stack Overflow, as always, has a solution for this. So we're just going to go ahead and do su root. And this will just be the same password you use for your username normally, if you can enter it correctly. And you'll get something like this. And the next thing you want to do is you'll want to use a text editor to edit this file /etc/sudoers. I'm going to go ahead and use Vim, so I'm just going to go ahead and install that. But you can use whichever text editor you want. Yeah, and then under here, you're going to want to add your username, and then save that. And if we go into a new terminal and we try running this again, you'll see that we have permissions now. Go ahead and close that. These. And then we can make sure everything looks good. We see everything is English US UTF-8, so that's fine. So then we're going to just run these commands. And we see it's already installed, so that's good. Then we'll add the ROS2 GPG key. Then we can go ahead and update. Great. All right, so now that that is finished, we're going to go ahead and run the desktop install. And once that finishes, I will come back because this will take a while to finish. All right, so now that has finished. So we'll go on to the rest of this setup guide. So we can source the environment by running source/op ros foxy set.bash. And anytime you want to use ROS2 in the terminal, you'll need to run this command. So we can actually test out that ROS2 is working by testing out using the C++ Talker node that they have. We can see it's publishing and everything appears to be working. So now we can go on to step 4 and install ROS Noetic. So there's an installation guide for that. And we'll follow this guide here. And then just like with Foxy, we'll run the desktop full install. And I will come back when that has finished as well. Alright, so now that we finished installing ROS Noetic, we can go ahead and install VRX. So there is an installation guide for that. We're going to go ahead and choose option A, configure your host machine. You need to run these commands. So alright, and now we can go ahead and add the dependencies that we need. And I've already run these commands, so it will probably take longer when you're running these in your terminal. Alright, so now we finished that, we can go ahead and create our workspace and get the code. So VRX recommends creating this inside the home directory, inside of VRX workspace. We recommend putting inside an MRG directory, the VRX workspace, just because if you are, say you're not using a VM and you're dual booting, and you want to use your Ubuntu environment for other things other than Marine Robotics, then it's nice just to have all your MRG stuff all together. So we're going to go ahead and do that, but you don't need to do everything inside of an MRG directory. So first, do that. I just created an MRG directory earlier, so you don't need to worry about running that. But we're going to make an MRG directory, and then we're going to go into it. And then we're going to go into create a VRX workspace /src, and go into that. And so then they recommend, their directions say to clone the VRX source repo. We have a VRX repo right here. It's this repository over here. And the reason we do this is because we have a couple of custom models that we like to use in the simulation that VRX doesn't provide out of the box, that we built ourselves for other competitions like Roboboat. So in order to use those custom models, you need to clone this repository in the GT Marine Robotics group /VRX. There's a link right here. And so to do that, instead of running git clone vrx repo, we're going to just get this code here. And then we're going to run git clone that. All right, so now that has finished. So we can move on to building the VRX simulation platform. You might have noticed I accidentally created a VRX workspace inside of my root. So we'll just go ahead and take care of that right now. You'll see right there. So we'll just go ahead and remove that. Okay. So now we can actually build and run the VRX simulation platform. So since VRX is made in ROS 1, they actually just today upgraded to ROS 2 on their main branch. But we're still using the simulation from ROS 1, at least for the near future. So first we will source ROS noetic. And then we'll cd back into the VRX workspace. And then we can run catkin make to build everything. All right, so now that VRX has finished building, we can source the setup.bash. And then we can launch the simulation to make sure everything is working. All right, so we can see the simulation. We can see the USV there. You'll notice it's going rather slow because I'm on a virtual machine. If you gave it more RAM, more cores, then it would run faster. But ideally, if you dual boot, you won't have this problem as long as you have something like 16 gigabytes of RAM. All right, so we close this. You can just, in general, whenever you're running something in the terminal, if you just Control C, it will close that process. So now we've gotten VRX installed. That's good. So the next step is to install the ROS 1 bridge. So in a new terminal, we can run this command. Oh, let's go here. We'll just cd out. And then paste that. It's wrong. All right. And then the next step is to clone Virtuoso, which is the repo that we have all of our code in. So we go to MRG, and then inside of MRG, we're going to create another workspace to hold our ROS2 code. So if you look in our recommended structure, you have your VRX workspace, and then you also have your dev workspace, which is going to include Virtuoso and then other dependencies that we've cloned, like AutoWare Auto, STVL, and so forth, so on. So create a dev workspace directory, cd into there, create an src directory, and then we will run git clone and clone Virtuoso. And if we look inside here, we can see that that has cloned. All right, so the next step is to install OpenVDB. So OpenVDB is software that you need to run STVL, which is installed for step 9. Now, unfortunately, you have to build OpenVDB from source. So you have to clone the repo and then build it. You may find if you're using a VM or just in general, if you don't have enough RAM, that the build may crash and your VM may freeze up. If that happens, that means you won't be able to use STVL on your VM or your environment. But everything else should run perfectly fine. So if you're unable to install OpenVDB, just know that STVL won't work, but everything else should be fine. So on my VM right now, OpenVDB is crashing when I'm building it. So we're going to be skipping step 8, but you can try doing step 8, and hopefully it should work for you. Just note that it will take a while to build. Okay, so for step 9, we're going to clone STVL. So if we go to our terminal, and we're still in this MRG/dev workspace/src, and then we're going to run this command to clone STVL. And if we look, we can see that STVL is now cloned. So next we're going to install AutoWare Auto. And we need to compile we have to install the following tools. So this package, and some pip modules. So we're just going to run sudo apt update. Sudo apt install. And sudo rosdev init. Oh. And then rosdev update. So we've just gone through these 4 commands here. Okay, and so we're kind of doing this a little bit out of order, but now we're going to go ahead and source, in this case we're going to source Foxy. So we're going to run source/op/ros/foxy setup.bash. And what that's going to do is that's actually going to populate this ROS distro here with Foxy, so that when we run this VCS import, it's going to import the repos for Foxy and not for a different ROS distribution. So we'll run git clone. Cool, and if we look inside now, we see we have an AutoWare Auto directory. So cd into that. and then we'll run VCS import. And you'll notice you'll get this command VCS not found. So they should probably have this in their documentation, the installation for that, but you'll find this time it's not Stack Overflow, but GitHub issues. We can actually just run sudo apt install python 3 VCS tool, and that will get that installed for us. So now we can run that command again. And now we can export ROS version 2, and then ROS step install. So ROS step install is just going to install all the dependencies for all the packages that AutoWare Auto has. All right, so now that that has finished, we are done with installing AutoWare Auto. So we'll go ahead and install ublocks. So we want to go out of the AutoWare Auto directory. So we're in the SRC directory. Clone that. And then we want to clone Velodyne for the drivers for our LiDAR. And then for our Velodyne LiDAR, both AutoWare Auto and Velodyne have packages that have the same name and essentially do the same thing. Although we've had trouble with the AutoWare Auto Velodyne packages, so we ended up using the Velodyne packages for our LiDAR drivers. So as a result, you can't have two packages with the same name in the same workspace when you're building. So we need to remove the packages that AutoWare Auto has that are named the same as the one Velodyne has. So what we're going to do is we're going to go into drivers, we're going to go into AutoWare Auto first, and then you'll see there's an SRC directory. We're going to cd into that, and then you can see there's a drivers directory, and so we're going to cd into that. And in here you'll see that there's some packages called Velodyne nodes and also Velodyne driver. So we're just going to remove those. We check again, you'll see that those two nodes aren't there anymore. So now when we build, everything's going to go fine for that. So let's head back out to the dev workspace directory. And so here we're going to want to source, well, I'll do this in a new terminal. Here we're going to want to source Foxy. So remember, you need to do this every time you open a new terminal and you want to run ROS2. You need to source Foxy. And then we're going to run this command to install these other dependencies that we have, other than the ones that we just cloned. Okay, so the next step is then to actually build Virtuoso. So a couple things first, though. Because we're using a VM, and we don't really need to use we're not going to actually be using any sensors, physical sensors. We're just going to be using the simulation. We're just going to go ahead and comment out this dependency inside of dev workspace /src /virtuoso autonomy, because we don't need to build those. And then we're also going to, since in this case we don't have OpenVDB, if you actually try building spatiotemporal voxel layer, you're going to get an error saying OpenVDB cannot be found. So we're going to go ahead and comment that out, that dependency out from the Virtuoso navigation package. And then we can run this command to build packages up to Virtuoso Autonomy. And the first time you build, it will take a couple of minutes. This is not the first time I built it, so it's going relatively quickly. And it will just build all the packages that you need. And if this builds successfully, then you're good to go.